2 p.m. So I'm sorry, I'm supposed to start the attendance early, but it was not working. You don't have to take attendance now. You can do it during the class or after the class. Okay? And we do have a pub quiz at 3:30 p.m. today. It's open discussions, open notes, and it will be open for about 10 minutes. So make sure you have a laptop or tablet or phone. Okay? So last time we stopped here. I just want to finish the introduction, and we're going to start reviewing the math. I highly encourage you to participate as much as possible and remind me your name, especially because I'm partially blind. Okay, I don't see past the first row. I see you, but then everything else over there is fuzzy. Okay, so these are the realms of physics, and this semester we only focus on mechanics. Okay, and mechanics, of course, was developed by the great Isaac Newton. So at the time it was not called physics, it was called natural science. And he developed those 3 laws of motion that we're going to study this semester. And he also invented calculus. I guess he was bored at some point. He said, okay, I'm going to invent calculus. And then he used calculus to develop the universal law of gravitation. So he's the one who said it's the same force binding us to the earth and binding the earth to the sun and the sun to the Milky Way and the Milky Way to the other galaxies. Gravity is some kind of loop provided by masses. So take that back to Newton. He based his work on the work of Galileo Galilei, who is maybe one of the first one who said you should rely on observations and not necessarily on religion or philosophy. Right? He got in trouble for that, but as I already told you, connection. He had the right connection, so he was not burned at stake. It happened to someone else, but not him. He was just in house arrest. So connection. I very encourage you to get in a study group, talk to each other, help each other out. So Galileo, okay, he's the one who understood free fall. And he said something non-intuitive. If you take, for example, it goes like, regardless of their mass, all objects will fall at the same rate as long as you do not have air resistance. So I want to demonstrate quickly here. If I have a piece of paper, I hate to rip off my notebook. Anyone has a heavy textbook by any chance, or something heavy I can borrow? Thank you. What's your name? Maria. Thank you. Oh, MCAT. Remember, if you are studying for the MCAT, I highly recommend that you do the problem as we go along. So I have a very heavy MCAT book and a piece of paper. Which one will you reach the ground first? But we do have air resistance. It's full of air, otherwise we will not be able to breathe. So now if I put a piece of paper on top of the book, okay, so I'm shielding the paper from air resistance, what's going to happen? Right? So regardless of masses, object will always fall at the same rate, except if you have air resistance. So if you have for the MCAT, for example, a conceptual equation, if you go to the moon and you have a feather and a hammer, what do you expect? That's very good, right? Because there is no atmosphere on the moon. And he did that using, thank you, experiments. He did many experiments for that. Okay? Newton also worked on optics. So he's the one who did that famous experiment. You know, when you are a kid, you take a prism and you have light from the sun going through. And what's going to happen to the light? Very good. You're going to get a rainbow, right? So white light will be divided into its wavelength component. Its component will be wavelength, right? So that was done by Newton. So at the time, they were wondering about the nature of light. Is light made of particles or light is a wave? So you could not contradict Newton at the time. He was a genius, but he was not a kind man. Yeah, he's very famous to come up with all kind of tortures, right? If you dare contradict him. So at the time, he said light was made of corpuscles. Light was made of particles, and everyone shy away. Once he was dead, then there was this very famous experiment that showed light will behave like a wave. Okay, and you have to wait for Einstein, okay, to show that light has a dual nature. Sometimes it will behave like a wave when it's traveling through space, and sometimes it can behave like a particle, something that can tick. Okay, so for example, with a solar panel, light will kick out electrons and you can produce electricity. So Newton was not wrong. He was rarely wrong, okay? Light is both a particle and a wave. So you have optics here, was developed at the same time. By the way, if you go to optometry, for example, or if you have, again, to take the MCAT, I have a playlist where I go over optics, but using a lot of applets to help students out if you need help. Okay, so that's just a parenthesis. 19th century, the beginning of the 19th century, it was the Industrial Revolution. So that's when they developed thermodynamics. So thermo means start with a H. Heat, very good. Dynamics is the flow. So it's the study of the flow of heat, because they were making all those machines, heat engine, the kind that you have in a gasoline car, and they wanted to make them as efficient as possible. So that's the Industrial Revolution. And then at the end of the 19th century, you have electromagnetism, and Michael Faraday told you, no education whatsoever, just a curious mind. He came up with how to make electricity that we use today. Okay, so that was Michael Faraday. At that point, physics was on top of the game. It was, if you take a philosophy class, it's called deterministic. That means you could predict anything in the universe using math. So physics was able to predict the future in a way, and it could describe the laws of nature using math, right? So it was up there. And then came Einstein, and everything was weird again. And because of him and others, physics of the very small was developed. And then it was not deterministic anymore. We could not play God anymore, because with the very small, you cannot predict exactly what's going to happen next. Example, you all take a chemistry class and you learn about orbital, right? Orbital around molecules, when atoms, they combine together. Orbital around atoms. And orbital is just probability. It means it's impossible to know exactly where is the electron at a given time. Okay, you cannot even predict its speed or its energy. Okay, so it became probabilistic. And for example, and very weird as well. So quantum physics says, if I keep pushing on that wall long enough, at some point, I can go through the wall, right? And of course, it can take 1 billion years for me to do so. Okay, I will be dead by then, but it's not probability zero. That can happen. So this quantum physics is the quantum physics that was used to develop the electron microscope, right? So if you work in a lab, you have electron microscope. So it's using electrons, so very small, to highlight, I don't know, very small features. And this is thanks to the quantum physics. So all the technology that we use today is based on quantum physics, but it's all probability. Okay, so even at a level like, since you're in biology, like, I don't know, DNA, RNA, molecules, you cannot be deterministic. You cannot predict exactly what's going to happen next. But all you need to get the astronaut out of the space station is to apply Newton's law. Okay, you don't need quantum physics. 8 months, guys. So feel very sorry for them. You have 2 assignments for next week. If you have issues with the math, I can extend the homework. You can always get help. You can ask me questions after the class during office hours. You can find me Monday, Wednesday, Friday, but email me before. In AC2115 at 10:50. But you can shoot me an email and I will let you know where to find me. For the math, you can easily get help, like ask ChatGPT, for example, if you get stuck. Okay, and you also have an assignment based on this video to watch. So it's very easy. Any question? Yes. How do we submit the homework? Is it like the worksheet? It's in Canvas. So the worksheet is to do on your own. Oh. And I will go over it during the class. But all the assignments otherwise are in Canvas, including the pop quiz. Okay, so I rely a lot on Canvas because it helps me being organized, which I am not by nature. So it really helps me. So in physics, we will talk about physical quantities, and each physical quantity has a unit. So here are some examples. Length, distance, the unit will be in meter. Okay, so for all the equations, usually we do not use the British system. No one uses the British system, miles, yard, inch, feet, pound, except the US and maybe 1 or 2 other countries in the world. Even England gave up on its own units. You know, it was based on the king measurements, right? So that was 1 yard, that was 1 inch, that was 1 foot. So no, we use the SI unit, system of unit. Okay, so distance, the unit will be meter. Mass, unit will be kilogram. Time, the unit will be second. And something useful, even if you are taking chemistry, if you look at the unit, you can be reminded of the equation that you need to use. So let's say speed, you do not know which equation to use, but look at the unit. Meter is for distance or length, okay? And then slash means you divide. Second is for time. So speed is a physical quantity, and the equation is distance over time. Each time you have a slash over, that means per unit time. Okay, so that will be the distance covered per unit time. Is that clear? Okay, so acceleration, it's how fast you are getting faster. And you see, it's meter per second, which stands for, meter per second stands for speed let the stress out. You have to participate. You have to be very loud, right? So speed divided by time. Okay? So how we're going to find acceleration? It will be the change in speed over the change in time, right? Okay? Here is another example, force. So in the British system, unit will be pound, but in the SI system, unit will be Newton. Because we have to remember the great Newton. But actually, it means kilogram times meter per second per second. So can you find the equation to find the force? Kilogram stands for mass. Weight is in Newton. Weight is a force. Mass, we're going to see it's how much stuff you have, like the number of molecules. So mass times, what is meter per second per second? Acceleration. Very good. So you already have another equation. F equals m acceleration a. So mass times acceleration. You see? And you can use that even for your chemistry class or whatever science you are taking. Let's look at another example. Newton is for force. Very good. What is meter square or square meters? Distance times distance is area. Very good, right? So pressure is force per area or unit area. Example, the atmospheric pressure, okay, because if I take like a square inches, okay, you have a column of air going to space, so it has a weight. So that will be 50 pounds per square inches. So that will be pressure. So let me ask you something. How come I'm not flat? How come I'm not squeezed? If there is so much pressure pushing me, squeezing me, 15 pounds per square inches, yes. Very good. What's your name? Carlotta? You wanted to say something? What's your name? Gabby. Exactly. So you have pressure inside pushing out. You have pressure outside pushing this way. So you are in balance, right? It's not going to squeeze you. If you are going scuba diving, you know how dangerous it can be. Okay, because if your lungs here has atmospheric pressure and you go too deep, it's going to squeeze your lungs, right? It's especially a big deal when you're coming back up, right? You can have something called the bends if you do scuba diving. So anyway, power. So energy, the unit is the joule, okay? And power, the unit is watt, named after James Watt, but actually is joules per second. So joule is energy per unit time. So it means power is the rate at which energy is flowing. Okay? How fast it's being delivered, how fast it's being consumed. Okay, so let's go to math. So I know that sometimes it's too easy and sometimes it's very hard, depends on your background. So I will still go over some scientific notation. So you need scientific notation, and you need to know how to solve proportions, and you need to know how to convert, right? Making conversions. So in my Dropbox, you're gonna here in my Dropbox, you're gonna have PDF here, and you have one PDF for scientific notation and one PDF that goes over proportion. You have a tutorial for scientific notation also in the Dropbox if you need a review. For the proportion, the tutorial is not very complete, but you can always find help. Is that clear? So it's not an assignment that you have to do. It's just I recommend you to do it if you need a refresher. Is that clear? Okay. So scientific notation. So that's why it's better if you have a TI. I just want to show you how to use the TI with scientific notation. So scientific notation, we have a power of 10 and we have an exponent. And here it's always a number between 1 and 9. So that will be the Avogadro number. So that will be the number of stuff in 1 mole. So 6 times 10 to the 23. I just want to show you how to use your TI. So with your TI, you will say 6.022. And here is the trick. You do, who told me it doesn't have a TI? You did? You don't have a TI? Do you want to use mine, but you give back? Okay, it's my son. I will get in trouble. So 6.022, and then second comma, second comma. Okay, you do second comma, that will be the base 10, and then 23. So that way, you're going to save some time. Okay? Instead of doing times 10 raised to the 23. It's a shortcut. So, for example, be careful though, if you do 10 to the second. So 10 to the second is what? 10 times 10, which is 100. So with the TI, for example, you can say second comma, that will be base 10. Second will be 100. But do not do 10 E2. Do you understand? We'll do some more example. Okay, so for example, if you have 10 to the negative is here, 2, that will be 0.01, which is 1 over 100. You don't have a TI either? So if you do not have a TI, told you to get a TI, you can download the app for free on your phone. There is an app that you can download. I have it. It's called TI84, something like this. It's free. It's called Calc 84. It's a free app. Not for the test, it's just if you didn't bring it today. Okay, so because that's where students will make mistakes. It's not so much for during for conceptual questions. It's when it gets to computations. Okay, so if you are asked to turn that into scientific notation, how you do that? You start from here and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Because you find a number between 1 and 10. So that will be 5.4 times 10 to the 10. Okay? Is that clear? So I have a tutorial for that. Okay? So for example, if you want to use your TI for this one here, right? So 3.2 times 10 to the negative 6. So 10 to the negative 6 is 1 millionth. So it will be 3.2 second comma to the minus 6. Okay? Okay. And you have to do it as we do it because staring doesn't help. You have to do it. 10 to the 0 is 1. Anything to the 0 is 1. 10 to the 3 is 1000. Very good. And 0.001 is 1 over 1000, which is 10 to the negative 3. Okay. So here, multiplications, how you do that with the TI. I want to make sure that everyone is on board. First of all, it's good to use parentheses when you are dealing with scientific notation, especially if you are dividing. So 3 times 10 to the 6. Okay, times, you don't put a times, you can if you want, but you don't have to. 2 times 10 to the second. And you see you have the answer here. Okay, so that will be 6 times 10 to the 9. If you are too lazy to count, you can change the mode here. So you can change the mode. You say, okay, I want scientific notation. Here, 6 times 10 to the 8. So with your TI, by the way, make sure you're going to be in degrees, not in radian, in degrees. And you can be in standard notation or scientific notation. Okay? Things get complicated, not quite complicated, but tricky when you divide scientific notation, because there is something called pandas. And when you divide, it will always start with whatever comes first. So you always multiply or divide whatever comes first. So if you do not put a parenthesis around the denominator, it will first divide by 2 and then multiply by 10 to the 8, which is not what you want. So when you are dividing, always use parentheses, right? So you're going to do 5, second comma will be the base 10, 2, okay, and then you divide, open the parentheses, 2 times 10 to the 8, always. Because for the test, you're going to have multiple choices, and it's always one of the choices will take in account that mistake. Okay, so you want to be careful with that. Is that clear? Okay, so that the answer will be 2.5 times 10 to the negative 6. So I know it depends on students. You can do it in your head. You can do 5 divided by 2 is 2.5. And then 2 minus 8 is minus 6. Okay? How many seconds in a day? I just want to give you one trick. Oh, no, this one is easy, right? How many seconds in a day? 86. So in a day, yes, so you're right. So one day is 24 hours, right? 1 hour is 60 minutes, and 1 minute is 60 seconds. So that will be 86 what? 400, you're right. Seconds. Do you all agree? Okay, one thing you can memorize is that in 1 year, that's a trick, you're going to have pi, so easy to remember pi, times 10 to the 7 second. So it will be about 3.14 times 10 to the 7 seconds. Okay, so that's one way to memorize if you want to go faster. Otherwise, you will do in 1 year, you have 365 days. In 1 day, how many hours? 24. And then in 1 hour, you have 3600 seconds, and you will get the same thing. Any question? So if you still have issues, you can use Khan Academy. They have great tutorials that will take you step by step to understand scientific notation. You need scientific notation for chemistry as well. And then you need to know how to do conversion. Right? So, okay. So, power of 10. So this you're going to have in your equation sheet. So you can always print it out. You don't need to memorize it, but I think it's something you should already know. Each time, for example, you have kilo, it doesn't matter if it's kilogram, kilometers, 30K a month, for example, it always means the same thing. It means 10 to the third, so 1,000. Example, if you have 3 kilogram, that means 3 times 10 to the 3 grams, so 3,000 grams. So each time you see a K, kilo, that means 10 to the third. If you have 1 kilometers, okay, you substitute kilo by 10 to the third, so that will be 10 to the third, so 1,000 meters. Is that clear? So if you have a small file, for example, I don't think those files are very small. Maybe this one is small. Size 843 kilobytes. So it means 1,000 bytes. Is that clear? 1 byte is about 64 bits for my laptop, I think. Okay. Then you have, especially if you are taking biology, you use micro. So each time you see micro, you see the symbol is mu. It's a Greek letter. That will be 10 to the negative 6. So that will be 1 million. Okay? So for example, in biology, 3 micrometer, you substitute micro, okay, it's like a sticker that you remove, you substitute it by 10 to the negative 6. In chemistry, I don't know, 3 micrograms means 3 times 10 to the negative 6 grams. Is that clear? Centi means 10 to the negative 2. So 5 centimeters means 5 times 10 to the negative 2 meters. We are good? Okay, very important here. Mega means 10 to the 6. Very good. A million, right? So you have megabyte. My videos usually is like megabytes, gigabytes. And then huge, million of a million will be tera, like a trillion, right? So 10 to the 12. So example, between Switzerland and France, you have a huge atom smasher. So it's like they smash protons together. It's called the Large Hadron Collider. But to do that, you need enough energy, huge amount of energy, about 6.5 tera electron volt. Electron volt is a unit for energy. So a typical chemical reaction, it will be 1 or 2 electron volt. So tera electron volt means 6.5 times 10 to the 12. Right? Is that clear? So at the beginning here, energy price in Europe went up by a lot recently. So for example, at some point it was 91 euro per megawatt hour. So watt hour is a unit of energy. Mega means 10 to the 6. right? 10 to the 6. So in Florida, we have the lowest cost of energy in the US. It's about 14 cents per kilowatt hour. So if you want to know the price per mega, you multiply by 1,000, which is $140 per megawatt hour. Just to give you examples. Okay, question? Okay, so this you can print out if you want. Sometimes I will get back to that, but you can print that out if it helps when you are doing your homework. Okay, so this is just, can you see or do you have to magnify? Can you all see that? Okay, so just order of magnitude. Here you have distance or length. So that will be about the size of a nucleus, a proton, like a hydrogen nucleus. That will be 10 to the negative 15. The size of the atom of hydrogen, or typical size, will be 10 to the negative 10. What's the ratio between them? 10 to the negative 10 divided by 10 to the negative 15. So 10 to the 5, or 10, depending which way you go. And 10 to the 5 will be 100,000, right? So it means the size of an atom is 100,000 times larger than the size of a nucleus. So it means if you take, I don't know, ladybug, I like ladybug, and let's say this is the size of a nucleus here, the electron, the first electron will be around BBC campus. This is how much emptiness you have inside that atom. If you didn't get that, you can always take your TI. Okay, let's verify. Times 10 times negative 10. Okay, divide by 10 to the negative 15. So how much 10 to negative 15 goes into? So that will be a ratio. That will be 10 to the 5, and let's switch mode. So 100,000. Okay, so the atom is 100,000 times larger than the nucleus. Copy me? Okay. Virus, coronavirus, for example, heard enough about it. So it's 10 to the negative 7 meters. Can you convert in micrometers? So 1 micrometer is 10 to the negative 6. So 10 to the negative 7 divided by 10 to the negative 6. To see how many 10 to the negative 6 goes into 10 to the negative 7. How many times? Huh? Very good, 0.1. What's your name? Mathis? 10. So 0.1. Okay, so a virus is about 0.1 micrometers. To make sure that everyone is on board, I can do 10 to the negative 7 divided by 1 micrometer. So how many micrometers goes into 10 to the negative 7? And it will be 0.1. Obviously, it's really, really small. So it's going through everything, right? So 0.1 micrometers. Okay, so here you have order of magnitude in the universe. Here you have mass in kilogram. So for example, the mass of an electron is 10 to the negative 30 kilogram. The mass of a proton is 10 to the negative 27. What's the factor? How do you go from 27 to 30? 3, so it will be 10 to the 3, right? 10 to the 3 is 1,000. So it means that the electron is about 1,000 times less massive than the proton, right? It's actually 2000, but we are only talking about order of magnitude. That's why if you take chemistry, when you look at the atomic mass, do you take in account the number of electrons? No, only neutrons and protons. They have about the same mass. Neutron has a slightly more mass, but about the same. Okay? So here you have some numbers. Time interval will be in seconds. So let's look our life. It's average, right? It's about. So 10 to the 9 seconds. So do you remember in 1 year, how many seconds? Huh? Yes, about pi times 10 to the 7. So let's say it's about 10 to the 7 because we say about. So let's see. 10 to the 9 seconds for a human to live in seconds. Can you turn that into year? Will be 100. Okay, so we live about 100. Not sure about that. 120 maybe, but I don't know. That seems a long time, but maybe, you never know. Okay, age of the universe, you can also convert that in 2 years. So just to give you orders of magnitude, okay, it's huge, right? Okay, any questions so far? Oh, maybe we should touch on that. Let's touch on that a little bit. So this is for you to do on your own. So you can practice. And again, for those kind of computations, be free. You can ask ChatGPT, for example, you get stuck to make sure you get the right answer. It will take you step by step. Okay, or you can use Claude, is another AI, or Gemini. I think it's the one from Google, right? But make sure you do it because really for this class, you need basic arithmetic like that and algebra. And then the rest is conceptual questions. If you pay attention, that's not that hard. So how do we convert in miles? Which is very useful because in most of the country in the world, we are using kilometer and we are not using miles. Okay, we are the only country, maybe another country in South America, I'm not sure. But so it's very useful to go from kilometer to miles. So how to remember? If you like to run, okay, you always have those apps, okay, and they always tell you, oh, go for the 5K. 5K means 5 kilometer. Do you know how much is 5K? Exactly. So it's going to be actually, I remember like that, 3.1 miles. So 3.1 miles, right? So that's why I remember. 5K is about 3.1 miles, and then 10K is 6.2 miles. Will you remember that? Okay. Otherwise, you have the equation sheet. So if you have 100 kilometer, how do you convert that in miles? Exactly. So you use what is called cross, multiply, divide. So you make a diagonal here. Okay, so you cross the numbers along the diagonal and you divide by the left over and you get the answer. Okay, so that's going to be 100 times 3.1 divided by 5. What do you get? 62 miles. Okay? Or you can remember that 1 mile is 1.6 kilometer. You can do that as well. It's an approximation. Actually, 1 mile is about 1609 meters. But I remember this or I remember that. It's useful if you go to another country to know how to go from kilometers to miles. Okay? So there is a trick. If you want to go really fast and you want to go from miles to kilometer. So you see 1 mile equals 1.6 kilometer. So what you do, let's say you have a hike and the hike is 11 miles. And you want to know about how much is that in kilometer. Okay? Because, I'm not used to miles, I'm used to kilometer. So what you do, you take the 11 and you add half of 11, which is about, how much is half of 11? 16, 5.5. Yeah. So it will be about 17 kilometers. It's just a way to approximate because you are multiplying by 1.6. Okay. Otherwise, you just use your proportion. Is that clear? Okay. So the way I remember is with my app, 5K is 3.1 miles. 10K is 6.2 miles. And then you do a proportion. Okay, let's take another example. Do you want me to do more example or this is maybe easy? Okay, something else you need to know if you are traveling to another country. So if you step on a bathroom scale in America, you're gonna read pound. Okay, but pound actually is the unit for weight. And weight is a force. It's the force due to gravity. So weight usually is in Newton, except that with the British system is going to be pound. So on the bathroom scale, you are not reading your mass, you are reading your weight. So if you take your bathroom scale that you bought in America and you go to the mall and you step on that bathroom scale, it's not going to read the same thing. Okay, because your weight on the moon will be less. It's going to be divided by 6. Okay, because your weight depends on your mass, the mass of the planet you are on, okay, and the distance between you and the center of the planet. So if you go in space, I still have my bathroom scale I bought in America, and I tape my bathroom scale to my feet, and I go in space. What do you think I'm gonna read? The weight. No weight, right? I will be weightless. Okay, because there is no gravity. My weight will be 0. But not my mass. I'm still here. I still have the same number of atoms inside. So the mass will be the same, but not the weight. So in the US, we are reading the weight. Now, if you take a bathroom scale, you go to Europe, you are not going to read your weight, you're going to read your mass. Okay? So does it matter? Not really, because weight and mass are proportional to each other. Right? So we're going to see that weight on Earth is about mass times 10. But it's not the same physical quantity. Mass is a quantity of matter and weight is a force. Are you with me? So if I am 70 kilograms, which I'm not, sadly, I am in France, I step on my bathroom scale and it says 70 kilograms. In the US, to find my weight in pounds, you multiply by 2.2. Very good. Where did you learn that? In biology or something? No, you just know? No, that's good. That's good, exactly. You multiply by 2 or 2.2, which is about what, 140, something like this? 154? pounds, right? And from pounds to kilograms, you divide by 2. So it's easy to remember that factor of 2, right? Sometimes it's useful because they always tell you if you want to find the number of proteins that you need, if you like to work out, you take your mass in kilograms. Then you say, okay, I need that mass, but in grams of protein. So for example, if I am 70 kilogram, okay, I need about 70 grams of protein, animal protein, or at least 70%. That's what they say, okay? I'm not making a judgment here, okay? So if you have 200 pounds, what's going to be? It's going to be about your mass in kilogram, 90 something, right? No, let's say 100, you just divide by 2. But you are supposed to divide by 2.2. Is that clear? My point is, kilogram is a unit for mass, pound is a unit for force. So it's not the physical quantity. It's just confusing. Okay, let's take another example. So this you already know, right? How many seconds in 1 year? By 10 to the 7, exactly. 3.14 times 10 to the 7 seconds. 3 days in minutes, what you will do? You multiply 3 by 24 times 60 minutes times, that's it. 3 times 24 times 60. Okay? Is that clear? So it's just a review. 14? Okay, 14 is a good one. Okay, do you remember the 2.2? Okay, 1 kilogram is 2.2 pounds. So here we're going to have the same thing. Something useful to remember, 1 meter per second, again, is 2.2 miles per hour. Like 1 kilogram is about 2.2 pounds. So that way, you don't want to pull your hair over, all the steps you have to take if you want to convert. 1 meter per second is 2.2 miles per hour. So if you have 50 miles per hour, okay, you put a question mark here. So you want to make sure here everything is meter per second, everything is miles per hour. So you cross multiply, divide, get x. So it's going to be cross multiply, divide by 2.2. What do you get? It's about 25, a little bit less. 22. 22? So 23 meter per second. Thank you. Remind me your name when you participate. Rihanna. Rihanna and Ethan. Especially if you are in the back because you are all fuzzy. I don't see very well. I don't see at all. I'm not going to bother you with significant figures. Okay, that will be for the chemistry professor. You already have enough with the physics. What else? If you want to go from kilometer, for example. So if you have, okay, so in the US, speed is in miles per hour, right? For some reason, that should be per, but it's miles per hour. And in Europe, it's going to be kilometer per hour. So can you convert 50 miles per hour in kilometer per hour? And one mile is how much in kilometers? 1.6, 1.6, right? So 50 miles per hour. Okay, so 50. You see here, it's like a sticker. And 1 mile is the same thing as 1.6 kilometer per hour. Okay? And what do you get? You see, when you multiply by 1.6, it's like you multiply by 1.5, which means you take the number plus half of it. So it will be like 75, 75, 77, something like this, but you get 80 kilometer per hour. Okay? So if you see 80 kilometer per hour is a speed limit, you translate that as 50 miles per hour. Is that clear? If so 80 kilometer per hour, you can convert that into meters per second. Can you do that? Meters per second. So you will do what? 80 kilometer. 1 kilometer is how many meters? 1,000 divided by 1 hour is how many seconds? 3,600. So you go by and by and by and by. So 1, 2, 1, 2, 800 divided by 36. Question? So if you have any question, you can come see me after. And so for example here, kilo stands for what? 1,000 grams, right? So if I want to convert 5,600 to kilograms, you divide by 1,000, that will be 5.6, right? 5.6 kilogram. And then you want that in pound, bless you, you multiply about by 2.2. Okay? So if something is not clear, just let me know. So last time, for those who are too shy to ask, you see, it's a proportion, right? So you do it this way. 50 cookies is for $5. Sounds like a deal to me. And then here are cookies. So you put 1,000 cookie is question mark. So you can do, otherwise you do it in your head, but otherwise you take the diagonal here, you multiply. So cross multiply, you divide, you get X, right? So it will be 5 times 1,000, so 5,000 divided by 50. Is that right? Okay, that's a lot. But you divide, right? Okay. I'm lost. Is it this one? No. I don't know where I am. No, I was not here, right? I was here? Okay. Okay, let's do this. That's the speed of light. So light travels very fast, but it's finite. Okay? So the speed is 300,000 kilometers per second. So per means for 1 second. So it's a speed. That means light will be able to travel 300,000 kilometers in 1 second. The moon is at a distance 382,500 kilometers. How long it takes for us to get the image of the moon? So how long it takes the light to reach us on Earth, right? How long? Yes, you're fast. Who said that? Right. 1.28 seconds. Try. Okay, so the light goes 300,000 kilometers in 1 second. So to travel 185, did I say 185 kilometer? It's going to be question mark. Is that right? No, it's a 500 here. Are you with me? So the time will be, you cross, multiply, divide. So it will be 385, 500 divided by 300,000. It's going to be about 1.28, 1.3 seconds. Yes? Did I lose someone?
Yeah, right.
Here?
Right.
No, it's right?
Yeah.
Okay, 1.3 seconds. So you don't see the moon as it is now, but you see the moon as it was 1.3 second ago. Isn't that cool? So it means when the first astronauts were on the moon, right, and they were talking to Earth, so he say, "Hi, how are you?" 1 second later, and then another second later, "I'm fine." So there was a lag, right? So when you look at the sun, you don't see the sun as it is now. So the sun is at 150 million kilometers away. So you see the sun like it was 8 minutes ago. Isn't that cool? So I think I told you that. So how long will you have to hug your friends if the sun will be to disappear? 8 minutes. 8 minutes. So it's long. No, it's like, so you have time to hug everyone. 8 seconds is half, right? So 8 minutes, and then everything is in coldness and darkness. Okay, any question? Okay, are you ready for physics? So again, if you have any question, I'm available after the class, and I am available before the class in AC1387. It's the hallway on the 3rd floor with all the chemistry, and I'm lost. I'm the only physics professor. It's mainly biology and chemistry. So let's start a new unit. All my PDF, okay, you will find them in Canvas. So we're going to start with kinematics in 1 dimension. Okay, so it's not too hard. That means you can either go to the right or you can go to the left. You just have to figure this out. Okay, so let's just discuss. So here you have a car moving along the number line. So this is called the number line. Height is positive. This direction is positive. That direction is negative. And you have the position of the car. So this is a dot. So that's the initial position. And then a little bit later, the next position, the next position, the next position. Between the dots, you always have the same time. What do you think about the speed? Is the car at rest, spinning up, slowing down? So every unit of time, you click it. So it's not at rest, obviously, it's moving, but it's moving at a constant speed. Very good. Because every unit of time, it's covering the same distance. So it will be a constant speed or constant velocity. So the dot, between the dot, you always have the same elapsed time. So second situation, you still have the same time between the positions. So what's happening to the car now? Acceleration, right? It's going faster. So for every unit of time, and it's the same, let's say for every second, it's covering more and more distance. So it means it's speeding up. It has a acceleration. We're going to see, and that's going to be something I will repeat over and over and over again. If there is an acceleration, there is a force, because they're going to be proportional to each other and they will have the same direction. Obviously, here, if you're accelerating, that's because you are hitting the gas. Okay? So the engine is pushing the car forward. The acceleration is to the right. The force is to the right. And the velocity is to the right. Agree? Okay, so this is the number line. Those dots are the position. We can decide that, for example, that will be the initial position if I want to. That's gonna when I'm gonna start the stopwatch. I start the stopwatch here, and I stop the stopwatch there. And maybe the origin will be here. So now what's gonna happen here? Decrease its speed, right? So it's gonna slow down. So which way is the force if you want to slow down the car? So it's going to be the brake, the friction. It's going to push the car which way? To the left. Very good. So the acceleration will be to the left. Even though the velocity is to the right, acceleration will be to the left. Acceleration means force also, force per unit mass. Okay, don't worry, it's just an introduction, but it will be typical conceptual question, you see? So mechanics has two branches, kinematics, so that's when you describe the motion. So you need time, acceleration, velocity, displacement. And dynamics is when you deal with what caused the motion to begin with. So that will be dynamics, right? We only focus right now on kinematics. So typical conceptual question. Kinematics, it's part of mechanics, and you don't do any reference to forces. Very good. See? Acceleration is part of kinematics, velocity, displacement, and time. That will be the physical quantities we're going to work with. Okay, let's get to our first definition. Average speed, not velocity. Speed will be total distance divided by the elapsed time. Unit usually is meter per second. So that will be the distance covered in 1 second. Example, okay, you can answer this question. I cannot see, but you can. And I don't have a calculator either because I gave mine. Not gave, huh? You borrow. Okay, so just when we have those kind of problems in class, you can talk to each other, you can help each other, you can discuss. So 190 miles per hour. So you have two ways to do it. You can use your equation. Speed is distance over time. And here you put a 1, okay? Because otherwise it's feeling unbalanced, so it needs something to stand on. And then all you have to do is a proportion. Or you can do 190 miles in 1 hour. So if you have 500 miles, it's going to be question mark. So you cross, multiply, divide, and you get do it on your own. If you forgot a calculator, you can download the app on your phone or computer. You have free app on the computer. You have scientific calculator on the computer if you have a computer or a tablet. I forgot, this is the age of tablets. What do you get?
2.63.
Okay, 2.63. 2.63. About 2.63 hours. So 2 hours and 30 minutes, about 2.63 hours. Okay? Are you with me? Okay. So talk to each other. Try to do the second one. Remember the trick. There's a trick here. So 1 meter per second is about 2.2. It's always the 2.2 miles per hour. British here and SI here. So just a review. So again, you can cross, multiply, divide, right? So it's easy. More you do in class, less you do at home. And time goes faster. That's Einstein said that. If you participate, it will accelerate the time. See, time is not constant. It depends on your frame of reference. Did you know that? If I was to leave you going very, very fast at the speed of light, and then I come back, you will be aging more than I have aged. Isn't that crazy? You could be 20 years older and I will be the same. So anyway, the answer is 86. Did you get that? Okay. In 5 hours, how many miles? Can you do it? Don't stare. Okay, we don't have an AI that will pop out the answer out of the screen. You have to do it, right? So 190 miles per hour in 5 hours. So you can use the equation if you want. Okay, you can say 190 distance IDK, hours is 5. Put a 1, otherwise it's going to fall. Did you get that? Okay, or you can convert here, right? You can say, okay, this is 5 hours, and you have a question mark here. Cross, multiply, divide, get X. Did I lose anyone? Everything is on board? Yes? Okay. Convert to kilometer. Remember the secret? 5K is 3.1 miles. So if you have 190 times 5, question mark. This is miles. So let's see, you have 190 times 5. So the answer was 950 miles times 5. Divide by 3.1. Did you get that? 1532 kilometers, everyone? Okay, do it, because if you just pay attention and then you think, okay, at home, I will do the computation, it never happens. You are too busy at home. It's better to do it in class, okay? Don't let anything go. Because if you say, oh, that's a detail, it will catch on you later. So don't let anything that you don't understand go. You can ask your friends or you can ask me, but don't stare. That's the thing. Okay, so this here, I didn't get to all of that yet, but it's a methodology that is very useful when you are doing science, when you are taking a science class like chemistry. On one side of a paper, for example, or if you are using a tablet, you want to define all the physical quantities that you will be using with the right units and the right symbol. So, for example, time will be t, unit is in second. Average speed, unit is meter per second. Distance is in meter. Okay? Always positive. We're going to see why. X for kinematics 1D will be the position on the number line. So it's a dot. Then you have the initial position. That's when you're going to start your stopwatch. You have the final position when you stop the stopwatch. We're going to talk about displacement. So I will define what is displacement. V will be the velocity. Initial velocity. What's the velocity when you start the stopwatch? Final velocity when you stop the stopwatch. Acceleration, how fast you are getting faster. And you have on the other side here, you have all the equations. Okay, so something you want to do for chemistry, for example, anything that uses equations. Okay, so let's do some examples. Again, easy. So, by the way, if you go to my Dropbox, here, okay, I have, oh, here is the video I was looking for. See, you have the videos here that goes over scientific notation, proportion, and you also have a video, a tutorial for the problems here that you will find in my slides. Do you understand? Okay, because sometimes students are too shy to ask questions, and so I made those videos. So I'm not going to do all of them in class, but if you need extra help, it will be in my Dropbox. Okay? So, okay, let's do number 4. Let's do number 4. So again, you can help each other, talk to each other. So don't stare, okay? Do it. Try to do it. Don't space out yet. Average speed in miles per hour. Okay, so you can do speed is distance over time. So the distance is 4.6 miles. What's going to be the time between 9 a.m. to 10:30? Very good. So 1.5 hours. So that's going to be about 3, right? So 3 miles per hour. Is that right? Okay. If you want to convert to meter per second, so you can use the trick. 1 meter per second is 2.2 miles per hour. So you have 3 miles per hour, question mark. When you divide 3 by 2, it's about 1.5, a little bit less because there was a 0.2. You cross multiply, divide. Do you all agree? So the speed will be about 1.4 meter per second. Okay? So do not hesitate to talk to each other, right? You need a study group. Okay, let's try to do the last one. So so let's check the unit. Here we need meters, here we need second. So the unit here is in meter per second. Always check the unit. So if you want the speed in meter per second, that means you divide meter per second. And here you open the parenthesis. So 1 minute is how many seconds? 60. 60 times speed. 180, very good. Who said that? What's your name? Muriel? Ah, Muriel, that's a French name. 180 plus 30. Do you all agree with that? So that will be 1500 over 210. Is that right? So bye-bye. So about 150 divided by 21. And you find 7.14. Right? Remind me your name if you participate, especially because I don't see much. Okay? Let's see. Okay, so here, it's 324. Let me just start here. So in physics, you're gonna have two kinds of physical quantities. You're gonna have what it's called scalar, and you're gonna have vectors. Okay? Example. Let's say you have a cockroach, right, looking for food. Boom, 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 boom. You know, it's very erratic. Okay? And it goes from point A to point B. Point A is called the initial position. Point B is called the final position. If I want to find the distance covered, right, makes sense to everyone, you can take like a mini surveying wheel and, you know, or a meter tape, and you go and measure that distance here. So that will be the distance. It will have a magnitude, I don't know, maybe 2 yards, for example, and a 2, the magnitude will be 2, and the unit will be yards, or 2 meters. So that's a scalar. But in physics, we introduce a different kind of mathematical object, and we call that vectors. So to find the vector displacement, so we're going to see displacement is a vector. That's just an introduction. What you do, very easy, you start from the initial position, you make a line here, and you go to the final position. So that's called a vector. It means what matters is only the initial position and the final position. So a vector is like an arrow. It has a tail, so this is called the tail, and this is called the head. The tail is attached to the initial position, and the head is attached to the final position. So in physics, okay, there is a difference between distance, so that will be the distance, and displacement. So displacement has a magnitude, okay, so that will be that line here, a unit, but also a direction. So, for example, that could be 30 degrees north of west. Okay? So I will explain that in more details, but I invite you, to start looking at your textbook. You all need a textbook, right? I told you which textbook to get. And look at vectors versus scalar, right? So this here is called a vector displacement, and this is called the distance. So I still have 1 minute. Let me ask you something. Okay, so to get the displacement, you connect initial position to the final position. Okay? So far, so good? So let's say I have like the zoom, I start to run all the way to the window, and then I come back to the same position. What's going to be my displacement? 0. Excellent. 0. It's weird, but that's how it's defined, because you go back to the same position. Is the distance 0? No. You have to take a meter tape, go all the way, and then come back. Okay? So to find the displacement, you connect initial position to the final position. This is the tail, this is the head. Okay? So this is in 2D, but we're going to work in 1D for now. So it's going to be easier. So just an introduction. So a vector, okay, is a mathematical construction. It has a magnitude, how much, a unit of what, and a direction. So for example, I'm going to drive 30 miles north of BBC campus. 30 is the magnitude, miles is the unit, north or northwest is the direction. If I say I'm driving 30 miles, that will be a scalar. It has a magnitude and the unit. Okay? So in 1D, it's going to be easy. How many directions you can go about? 2. So we say to the right it's going to be positive, and to the left it's going to be negative. Very good. So the displacement can be positive, or the displacement can be negative. Okay? I don't know. I think, is that open, the pop quiz?
Yeah.
Oh, okay, sorry. So, of course, it's open discussions. You can help each other. You can move around if you want. It's only open for 10 minutes or so. You can ask me questions if there is something you do not understand. It's based on the previous lecture. But I highly recommend that you make new connections and collaborative learning